All right, welcome back. In this video, I'm going to solve this question you see right there on my screen. It says, if f is a function defined from the domain negative pi over 6, comma pi over 6 to I, is defined by f of x equal to 2 to the power of x times 3x for all x in the domain. Then f prime of x is what? So again, we're going to solve this question using the product rule because the given function is a product function. And by the time we are done with the solution here, we'll move over to GeoGebra and also solve it using GeoGebra as a tool where we see the graph of the function itself and the graph of the derivative of the function. So please follow along closely as I solve this question. Solution. All right. So now, let's recall the function again. So the function defined from this given domain, negative pi over 6 to pi over 6, an open interval. So f of x is equal to 2 to the power of x times 3x. Like I said earlier, this is a product function. So meaning we are going to use the product rule to solve this question. Let's quickly recall the product rule. The product rule states that if y is a product function, uv, where u and v are both functions of x, then y prime will be equal to u v prime plus v u prime. So here we are going to differentiate both functions u and v with respect to x. So here I'm going to say let u be equal to the first function of x, which is 2 to the power of x, and v be equal to the next function of x, that is equal to tan 3x. Differentiating u with respect to x, this is going to be equal to 2 to the power of x ln 2. That is the natural log to the base e2. This is a specific rule of differentiation. If you don't understand how I did this differentiation, please look at or try and watch my earlier videos on some rules of differentiation. And the v prime is equal to sec squared, 3 sec squared 3x. Again, all of these are entailed in the basic or standard derivatives, which I've done some video on earlier on. So now we've been able to differentiate u and v. We can go ahead and substitute in the formula. So therefore, u prime of x will be equal to u, which is 2 raised to the power x, v prime, that is times 3 sec squared 3x plus v, which is tan x, v is tan 3x, u prime, and u prime is 2 raised to the power x ln 2 log to this e2. All right, so here's the derivative of the function, and something is common. 2 to the power of x is common, so we can actually factor out that term. 2 to the power of x times 3 sec squared 3x plus 3 sec squared 3x plus ln 2 times tan 3x. So here right on my screen is the first derivative of the given function f of x equal to 2 to the power of x tan 3x. Then we'll go further and differentiate or substitute the value of x at 0. So f of x at x equal to 0, that will be equal to 2 to the power of 0 times 3 sec squared. 3 times 0 plus ln 2, the natural log of 2 times tan 3 times 0, which is of course equal to 0. So by close observation, you would agree with me that this over here is 0 because sin 0 is 0, and 0 times ln 2 is 0, so everything at this right hand side is 0. And sec 0 is 1. So 3 times 0 is 0, sec 0 is 1, 1 times 3 is equal to 3. And here over this is 1, 2 raised to the power 0 is 1. Therefore, f prime of x is equal to f prime of 0 is equal to 3 finally. So here is the answer to this question. I hope it was very easy and the solution is straightforward. Okay, so let's look at GeoGebra. Here in GeoGebra, I'm going to define my function. Let me just ignore the domain of the function and assume the domain is entire R. So I'll start by defining the function f of x equal to 2 to the power of x times tan 3x. So that is the function, and here at the right side of my screen is the graph of that function, f of x. So let's differentiate f of x and see if the answer will arrive at, it's going to be the same thing as what we've done earlier. All right, so the derivative here in GeoGebra is 3 times 2x squared, 2 raised to the power of x tan squared 3x plus 2x times 3x then 2 plus 3 plus times 2 raised to the power of x. Do you think in any way that this answer is different from this? Is the answer gotten in GeoGebra, do you think it's different from this in any way? Of course, no. Remember that there is a trigonometry identity, sec squared x is equal to 1 plus tan squared x. So the truth, when you substitute this trig identity into this derivative over here, you should arrive at the same answer as this, exactly as this. So try it out, pause the video, try it out and see if that will be the same. So by further investigation, to also confirm that this answer is actually the same, let's find the first derivative at 0 and boom, that is 3. So which coincide with our answer earlier, 3. So I believe you enjoyed this video and I believe it was explanatory enough. So please keep on like the video, subscribe to the channel, and for more videos, more interesting videos of this nature. Thank you for watching. Have a wonderful day.